Concrete works is one of the main activities in construction, the labor cost of which would have to be estimated properly so as not to exhaust manpower or assign more people than needed for the activity. Learn about it here in Construction Engineering and Project Management. According to the DPWH Bluebook, concrete works have been categorized into pavement and structural. For Portland Cement Concrete Pavement, or PCCP, standards are placed in Item 311. Estimating labor is dependent on materials, where cement is taken between 9 to 10 bags per cubic meter of concrete. The aggregates will also be standardized accordingly as how concrete works are estimated. For labor estimates, batching and casting in place will be done using different equipment. One is the one-bagger mixer with a capacity standardized at 180 bags per day. Take note that this is for 2 units of the machine, as it is assumed that PCCP is a massive project of roads or highways. So if we take the capacity of 1 unit of the mixer, that is 180 divided by 2, giving us ideally 90 bags output per day for 1 mixer, or in reality, the adapted capacity is 70 bags. Note as well that the required entities through cubic meters of concrete, but the available resources or capacities through bags, so in order to reduce the computations, we might as well turn the capacity in cubic meters instead of bags. So taking the standard material of 10 bags of cement per cubic meter of concrete, divide the capacity of 70 bags, thus the new capacity is 7 cubic meters per day. This time the capacity will be consistent with the required. With the said equipment, the crew members required for 2 units are the following: 1 civil engineer, 1 material engineer, a laboratory technician, 1 foreman, 4 masons, 2 carpenters, and 24 laborers. The next equipment used for concrete works is the transit mixer. Depending on how large the equipment are, the standard capacity of most is 3.6 cubic meters per trip. The crew members would also have to include the 2 locations. Some working at the batching plant are the 4 laborers and 1 materials laboratory technician, and the others are at the project site. They are the civil engineer, 1 material engineer, 1 material laboratory technician, 1 foreman, 2 masons, 2 carpenters, and 10 laborers. Let's use the standards through an example where we are to determine the duration of concrete pouring for an 8-lane highway with a length of 1 kilometer, the thickness of which is 8 inches. So either we compute for the bagger mixers or transit mixer, the volume is to be computed. That would be taken as 1 kilometer length with a thickness of 0.2 meter for 8 inches, then 8 lanes with the standard width of each lane as 4 meters will be the width. The volume is then computed as 6,400 cubic meters. So now we can compute the duration of the job using 2 units of bagger mixers, which is taking the ratio of the 6,400 cubic meters with the 2 mixers of the capacity of 7 cubic meters per mixer per day, so it gives 457.14 days to complete the length of the highway. When using the transit mixer, the volume of 6,400 cubic meters will be divided by the capacity of 3.6 per equipment, so that would be 1,777.78 trips. The duration in days will be dependent on how many trips the transit mixer can make, and this is affected by the distance the transit needs to travel from the batching plant to the project site. The next division in concrete works is structural concrete, where procedures will also be similar with those placed in Item 311 under Portland Cement Concrete Pavement or PCCP. Some notes to consider for structural concrete are: first, the duration of the use of the bagger mixers depends on the scheduling of activities. Second, the crew members for both bagger mixer and transit mixer are similar with the PCCP. And lastly, the duration of the transit mixer will also be dependent on the distance of travel and the number of mixers available. For structural concrete though, the crew members will consist of the following: a foreman, 2 masons or carpenters, and 15 laborers. The gang activities will include form installations. According to the Bluebook, there are standard numbers of manpower per equipment, but how if the available gang does not fit the standard? We need to recompute the concrete work factor to estimate the duration of the job properly. And again, the standard number for a bagger mixer are 1 foreman, 2 masons or carpenters, and 15 laborers. For transit mixer, a gang consists of 1 foreman, 1 laboratory technician, 6 skilled workers, and 10 laborers. Activities will include forms installations. To adjust the number of manpower from the standard, the workforce is taken as capacity over the number of men per gang. To make the discussion clear, let's have an example with a scenario of pouring the second floor of a building with computed volume of 39 cubic meters. The available manpower at the time are 1 civil engineer, a foreman, 3 skilled and unskilled, and the equipment are 1 bar cutter and a bagger concrete mixer. So it shows that we are going to use the 1 bagger concrete mixer. So let's start by comparing the available manpower with item 405, stating that the crew members for a bagger mixer are 1 foreman, 2 masons or 2 carpenters, and 15 laborers. By adding the individual workers, the standard manpower is 18 men in 1 standard gang. Let's try to convert the output or workforce by taking the ratio of the capacity of 7 cubic meters per gang as discussed earlier, with that of the 18 men per gang, and that would be taken as 7/18 output in cubic meters per man per day. Now, let's take the available manpower from the gang, so add 1 plus 3 plus 8 is 12 men for the available gang to do the job. So the 12 men will be multiplied with the output of each individual of 7/18 cubic meters per man per day, and that would be 4.67 cubic meters per man gang per day. Thus, the duration will be computed as the required volume of 39 cubic meters divided by 4.67 cubic meters per man gang per day, and that is 8.35 days. On the other hand, what will happen if the available manpower exceeds the standard? That is, instead of just 18 people on site, there are more. Are we gonna work on a different workforce? Well, in this case, the standard capacity of 7 cubic meters per gang per day will still prevail, as the additional workforce cannot make the process of mixing concrete in the bagger faster.